Another key feature of the graphs are the average rate of change. So with average rate of change, you're basically finding the slope between 2 points and seeing how quickly it increases or decreases. So the formula may look familiar to you. This is the formula right here. It's the formula of slope, y2 minus y1 over x2 minus x1, the change in y over the change in x. So what we'll always give you when we're finding the average rate of change is what interval we want to find it in. So the interval is written like this, and they always give you the x values. The interval could also be written as an inequality, like this, or like this. These two mean the same thing. I feel like I could say anything right now because no one actually listens. All right, so since we're finding the average rate of change between 1 and 3, these are our x values. This is our x1 value, and this is our x2 value. So for each one of these, we're going to find 2 points, and 1 and 3 are the x values. So you simply have to find the y value that goes with it and plug it into the formula. These are just, we give you different ways to look at functions. So when x is 1, y is negative 6. When x is 3, y is 20. And then you simply plug it into the formula. Subtract the y's, subtract the x's, and we get 26 over 2 is just 13. So the average rate of change between 1 and 3 is 13. That means it's a really, really steep line. It's a really, really steep change. So that's what we're looking for, the steepness of the change. So for this one, the average rate of change between 1 and 3, remember we're looking for the x values. So those are them. So the 2 points are 1, negative 4, and 3, negative 6. And we simply do the formula. Negative 6 minus a negative 4, 3 minus 1. So negative 6 minus a negative 4 is negative 2 over 2. And so this average rate of change is a negative 1. That means it's going down with a slope of negative 1. Okay, this one here, you recognize this as a parabola. So we're still looking for a point where x 1 is 1 and x2 is 3. So to do this one, we actually have to physically plug it in to find the y. So we plug our 1 in and figure out our number. So the value is negative 2. And we want to plug in 3. So when we plug that in, we get a 2. So now we just do the formula on that. So that's the basic idea behind the average rate of change, is we are just finding 2 points. So 2 minus a negative 2 and 3 minus 1. And then this is 4 over 2 or 2. So the average rate of change here is 2. It's a bit steeper than the table of values over here, which is 1. Here. This one's a little steeper. It's going up a little steeper, and negative 1 is going down a little, not so steep. Okay, this one is just another type of notation. This is our function notation. But remember, this is f of x, so this is the value in there is x, and the value that it's equal to is y. So we want the points 1, 2, and 3, negative 2. Plug those into our formula. Negative 2 minus 2, 3 minus 1, and we get negative 4 over 2, and that's negative 2. So these two actually have the same rate of change. These are exact, this one and this one are exactly the same. This one's going up at 2 and down 2. So let's say you were, I don't know, earning money at $2 an hour. So here you're making $2 an hour. Here you're losing $2 an hour, but you're still, the change is still the same between the two. So which of the following has the largest average rate of change in the interval? Well, that's 13. The largest rate of change is 13. So that is the graph. Which of the following functions has the smallest rate of change? Well, the smallest rate of change is the smallest number. So it's technically the absolute value of each. So technically this is the smallest value, but this is the actual smallest rate of change. Which line isn't the steepest? So when it's the largest average rate of change, we want the steepest line, so the one going up really fast. The smallest rate of change is the one whose slope is kind of slow, like one you wouldn't mind walking up. And that would be the table of values. And as we said before, these two, this one and this one, have the exact same rate of change. All right, have a good day.